So for these next two functions, we want to do A through J. We're going to find the domain, we're going to look for holes in the graph, find all of our asymptotes, find all of our intercepts. We're going to actually find a few more points on the graph, and I'll show you how I work my tables out. Sketch the graph and then tell what the range of our graph is. Let's see if we can get all of that done on this page. So here's our function. We need to say what the domain is. The domain, we set the denominator equal to 0 or not equal to 0. So add 2. X cannot be 2. Subtract 3. So x cannot be negative 3. So our domain would be negative infinity to negative 3, negative 3 to 2, and 2 to infinity. So that's the domain. We want to list any removable discontinuities or holes. Remember, that happens if you can reduce your fraction. None of these will reduce. That means there are no holes or no removable discontinuities. We're supposed to find all the vertical asymptotes. Well, the vertical asymptotes come from looking at the denominator. X minus 2 equals 0, x plus 3 equals 0, so x equals 2 or x equals negative 3. These are your vertical asymptotes. Let's go ahead and graph those. Vertical asymptotes are always vertical dashed lines. So x equals 2 would look like this. X equals negative 3 looks like this. So this function has two vertical asymptotes. We want to find any horizontal asymptotes. Well, if I were to multiply all this out, I get degree 2. Actually, let's go ahead and do that. What I'm going to do is multiply all of our factors back out. At some point, you can go through this particular step without multiplying everything out, but most of the time you're going to be given a function that's multiplied out already, like this one. So you have to go back and factor it anyway. Alright, so if we multiply this out, 2x times 2x is 4x squared. This would give us a 2x minus 2x is 0. So negative 1 times 1 is negative 1. Here we have x squared. 3x minus 2x is a positive x. And then negative 2 times 3 is negative 6. So this is what our function looks like if it's... Sorry about that. This is what our function looks like if it's not factored. The degree here is 4. And the degree here is... Excuse me. The degree here is 2. And the degree here is 1. When the degrees are the same, you make a fraction out of the leading coefficients. So remember, that's a 1. We make a fraction out of that. We get y equals 4 over 1, which means y equals 4 is our horizontal asymptote. Okay, the next is to find oblique or slant asymptotes. Well, that happens when this degree is 1 more than this degree. And that is not happening here. So we don't have any oblique asymptotes. The next thing is to find all of our x-intercepts. You find these just like we've always found x-intercepts. To find an x-intercept, you let y equal 0. So back up here at our function, we write all this down, but y is 0. So we have 0 equals all this stuff. Okay, and then we solve that. To solve it, we need to multiply both sides by the common denominator, which is x minus 2, x plus 3. If you multiply the left side, you just get 0. If you multiply the right side, all these go away. So all that's gone, you just get the numerator. Set them both equal to 0. We're going to add 1 and divide by 2. We're going to subtract 1 and divide by 2. So our x-intercepts are the points 1/2, 0 and negative 1/2, 0. Okay, the next thing that we want to do is find the y-intercept. To find a y-intercept, you let x equal 0. I'm going to go back to this form right here. If you want to go up here, it'll still work. You just put a 0 everywhere there's an x and simplify everything. But if we put the 0 in here, you'll see that it works out a little bit more nicely. So we have 4 times 0 squared minus 1 over 0 squared plus 0 minus 6. Well, that's 0 minus 1. 0 plus 0 minus 6 is negative 6. So we just get 1/6. So our y-intercept is the point 0, 1/6. The next thing we want to do is find a few more points on the graph. That means we need a table of values. Now, to get my table of values, I'm actually going to use my vertical asymptotes. So before I do that, I want to plot everything that I have already. I already drew my vertical asymptotes. Y equals 4 is my horizontal asymptote. 1, 2, 3, 4. So this is my horizontal asymptote. I know 1/2, 0 and negative 1/2, 0 are my x-intercepts. 1/2 and negative 1/2. I also know that 0, 1/6 is my y-intercept. So something right here. Really close. So I need to use all of this information to come up with a few more points. So look at what we have on our grid. I can see that this is split into 3 sections using my vertical asymptotes, right? This side, the middle, and this side. I like to get 3 points in each section. That's what I really like to do. So to get those 3 points, something crazy is always happening really close to your vertical asymptote. This is where x equals 3 or negative 3. I want to get something really close to that, like maybe negative 3.5. Okay, so I pick something really close like negative 3.5. Alright, I'm also going to pick something else like maybe negative 4. Just a little bit farther down the graph. And then maybe I can move way out here and pick something like negative 6. Keep in mind, it doesn't matter what x values you choose, but you want to choose them smart enough so that they show you what your graph looks like. Okay, so those will give me 3 points on the left side. I already have 3 points in the middle, but I'm not really sure what's happening on these 2 sides. So I might pick maybe this point, negative 2, and maybe a 1 for this side. So I'll pick negative 2 and 1. And that'll be enough for the middle. And then I need to pick 3 on this side. So I'm going to go to my vertical asymptote, which is at x equals 2. and I'm going to go right next to it. So I think I'm going to pick 2.5. So here's 2.5. I might go to 3, and then maybe come out here 5 or 6 or 20, whatever you want to choose. So we did 2.5. I'll choose 3 and maybe 5. Now that we have all of these values, your trusty little calculator comes in handy. Seriously comes in handy. Store -3.5 and then type it into your function. You can use this form or you can use this form. Either one works. This one has less parentheses, so I'm going to use this one. So remember, we just want to graph these, so getting decimals is fine. 17.5 is approximately what we would get for that one. Okay, so let's go through and do all of these. Store -4. Now on my calculator, I do second enter, and it recalls the line above and then the line above that. So second enter gives me this line. I don't want that one. So second enter gives me the line above that. That's the line I want. That way I don't have to retype everything. I get 10.5. Some of you have, you know, the cooler new calculators, and you can just scroll up using the arrows. You can scroll up and grab it and then push enter. Mine, you can't do that. So -6 stow x enter. Second enter, enter. I get about, that's almost 6, right? We'll put 6 there. -2 stow x enter is about -3.8. That's about -0.8. 8.7. 5.8. and 4.1. Now that we have all of these, plot these points on the grid. 17.5 is way off the grid somewhere. So to graph this one, it would be off the grid. So -4, 10.5 is as well. So what's happening is it's getting smaller. So it went from 17, which is way up here, down to 10. And then at -6, 1, 2, 3, 4, 5, 6, it's up at -6 or +6. 1, 2, 3, 4, 5, 6. So it looks like it's doing something like this. Okay, let's do the middle ones. We have -2 and -3.8. And we have 1 and -0.8, something like this. So in the middle, it looks like it's doing this-ish. Alright, and then we have 5, so that's 2, 3, 4, 5, and 4.1. It's really close. Oh, I jumped over. I went to this one. So we also have 2.5, 8.7, and 3, 5.8. So 2.5, 8.7, so that's 4, 5, 6, 7, 8.7, and we also have 3, 1, 2, 3, 4, 5.8. So this side looks something like this. So let me just say that I know you are able to graph these on your calculator. I know you can do this. I even show you how to do this, right? So because I know you can do this, you can totally match this to a matching question on a test. But that will not show me that you know how to do all of this, right? I will be looking for this table and all these little bits and pieces along the way. There are a few things you could leave out, like right here. We already know that the x-intercepts are where the denominator is 0. So if you just write your x-intercepts, I'm okay with that. Even for the domain, you should know that that's going to give you a 2 and that's going to give you a -3. So if you leave out some of this work, that's okay. But definitely don't leave this off, because this is very important for this particular problem.